So for this section, it's asking you to use one trigonometric value to find other. So if you're given one trig value, you can actually able to use that information to find the other 5 trig functions. So in this first example, if cosine theta equal to 5 over 13, find the other 5 trigonometric values, trig values, for the acute angle theta. So if we were to go back to the trig function, we remember that cosine theta is equal to adjacent over hypotenuse. So 5 is the adjacent side and 13 is the hypotenuse side. So if I were to draw my triangle in this example, you have to draw a picture to better see it. So I'm going to draw a triangle, a right angle triangle. So it doesn't have to be perfect, doesn't have to be exact, as long as it's a triangle where one corner is a right angle. Now, if I were to use the acute angle, now these two are acute angles, so it doesn't matter where you put it, as long as the information that you use were put on the correct spots. So, say I decided to label this as my angle theta. So my adjacent, meaning that the side next to the angle, is 5, so the side that's next to the angle right here is 5. Now the hypotenuse, the longest slanted side, the hypotenuse is 13, so I'm going to put 13 here. Here we don't know the opposite side, the side that's across from the angle, so I'm going to label that as x. So if we were to find the value of x, if we go back from geometry, this is a right angle triangle. So if we go back, if we use the information remember for a right angle triangle, we could use the Pythagorean Theorem. So here I'm going to write it. Pythag. Let's put that. So Pythagorean theorem. So given a right angle triangle, the Pythagorean theorem is a squared plus b squared equals c squared. So in this example, a squared is usually the shortest side, but it doesn't matter what we have if we're looking for one of these sides here. And we know that c is the longest, the hypotenuse side. So I could use 5 for a, or I could use 5 for b, and then I use x for the other letter. So in this example, let's say we use 5 for a. So that means 5 parenthesis square plus, and I'm going to use x for b, so x square equal, and remember c is always the hypotenuse, the longest side, so 13 square. Now if we were to work them out, so 5 squared is 25 plus x squared equal 13 squared is 169, and to solve for x squared, I would subtract both sides by 25, so now we have x squared equal 169 minus 25 is 144, and I'm going to write right here x squared equals 144. Now just to get x by itself, I need to get rid of the square, so I'm going to do the opposite of square, which is square root. So since I did it on the left, I gotta do it on the right. So x squared is equal to the square root of 144, which is plus and minus 12. Now, whenever you ever do a square root of a number, you have to keep in count that sometimes you have two answers, a positive 12 and a negative 12. Now, when we're dealing with sides, the length of a side, any measurement of length will always be a positive number. So in this case, x will be positive 12. And then we can just ignore the negative 12. So here, x is positive 12. So that's how you're going to apply the Pythagorean Theorem to find your missing side. Now, we're going to use all the information given here to find the other 5 trig values. So what I'm going to do is, I'm going to make room by erasing the Pythagorean Theorem work. Now, we have cosine, so let's do sine. So sine theta is usually opposite over hypotenuse. So opposite from the angle is 12 over the hypotenuse, which is 13. And then tangent will be opposite over adjacent. So tangent on the top is the opposite, so across from the angle is 12 over the adjacent, which is next to the angle, 5. So 12 over 5. Now, cosecant theta ties into or related to sine theta, meaning the reciprocal of this or flip of this. So hypotenuse is on the top, which is 13. And then the opposite is now on the bottom, which is 12. Secant theta is related to cosine theta. So basically the flip version of it, the reciprocal. So hypotenuse is on the top, which is 13, over the adjacent side, which is now 5 on the bottom. And then, I don't have room, so I'm going to write right here, cotangent theta is the flip version of tangent theta. So adjacent is on the bottom, now adjacent is going to be on the top, which is 5. And then opposite is on the top for tangent. So for cotangent, opposite is on the bottom, which is 12. So sine theta is 12 over 13. Tangent theta is 12 over 5. Cosecant theta is 13 over 12. Secant theta is 13 over 5. And then cotangent theta is 5 over 12. So again, all we did was use the trig function. Using one given trig function here, use that information to make our triangle. Use Pythagorean Theorem to find the other 5 trig function using the trig function that was introduced at the beginning of 4.1. In this second example, we have the same question, but now we have given tangent theta is equal to 4 over 3. If we were to review with tangent theta, tangent theta is opposite over adjacent. So that means opposite is 4 and adjacent is 3. So if we were to draw a triangle, again it has to be a right angle triangle. So right angle. Now in here, I can choose that to be theta, or I can choose that to be theta. Doesn't matter. But say I use the top up here to be theta. So if I choose that to be theta, then my opposite from the angle, so it's going to be across, will be 4. My adjacent will be the one that's next to the angle, which is 3. So we have one missing side. In this case, it's the longest side, so the hypotenuse. So again, we're going to use the Pythagorean Theorem. So a squared plus b squared equal c squared. Now again, you can choose 3 to be for A or for B. It doesn't matter for which, because we have two sides and we're looking for the hypotenuse, which is C. So we can choose 4 for A, doesn't matter. But say that I did that. So 4 squared plus 3 squared equal, and since we're looking for the hypotenuse, which is x, so x squared. So 4 squared is 16, and then plus 3 squared is 9, which equals to x squared. 16 plus 9 is 25, which is equal to x squared. So 25 equals x squared. If I were to flip it, it would be x squared equals 25. Now, just to get x by itself, meaning I have to get rid of the square, the opposite of square is square root. So again, I'm going to do the square root on the x squared. So since I did it on the left, I got to do it on the right. So the square root of x squared is just x equal the square root of 25 is 5, positive and negative. And again, when we're looking for the length of a side for any given shape, object, anything, when it comes to length, we always use the positive number. So x equals 5. So in this case, x equals 5. Now, we have to find the other 5 trig functions. Here we have tangent, so we have to look for sine, cosine, cosecant, secant, and cotangent. So it doesn't matter which order you do when you're looking for the 5 trig function, as long as all of them has the correct value. In this case, we're looking for the exact values for those trig function. So exact value, I need to make a little note. So exact value are just basically fractions. So the fraction that we have for the trig function. So let's review. If we were to start off with cosecant theta, we remember that cosecant was hypotenuse over opposite. So we know our hypotenuse, which is 5, and then we know our opposite from the angle, which is 4. Now we do cosecant theta, which was hypotenuse over adjacent. So therefore, hypotenuse was 5, adjacent was the one next to the angle, which is 3. And then cotangent theta was adjacent over opposite, which was, adjacent was 3, since it's next to the angle, and then 4 was the opposite, so it's at the bottom. Now, sine theta was opposite over hypotenuse, so 4 over 5, and then cosine theta was adjacent over hypotenuse, so adjacent was 3 over 5. So we found the 5 remaining trig function, and then each of them that equals to a fraction are called exact values. Exact values. So when it comes to the question where it says find the exact values of the trig function, it usually means a fraction. And then you have to identify which one is for the opposite, which one is for the adjacent, and which one is for the hypotenuse. So we use the information given from tangent theta equal to 4 over 3, drew the triangle, used the Pythagorean Theorem to find the missing side length, and then use all the information from the triangle to identify cosecant, secant, cotangent, sine, and cosine.